Hello, distributed students. This is Matt Richardson, one of your classmates. Uh, John Healy has asked me to do a quick tutorial video on how to implement RPC in Go across Docker containers. So let's just do this live. We're going to create a folder for our master, and within that we're going to create a file, so master.go, and set our package to main. I said main, there we go. Of course, because we have a main package, we're going to need a main function. So an entry point. Okay, so first things first. Um, just reading my notes here. Okay, so we're going to create an API. So just a simple API, just make it an int. It doesn't actually have any value to it. We're just going to use it as a pointer. And we're going to create some functions in here. These are actually going to be methods. But first let's generate them as functions. So let's create a server function. And this will actually do our handling of requests. So we need to create an instance of our master, which is a new API. Now we can start making this a method for exporting. Well, actually, we're not going to export the server. Now I think about it. This is just going to be a local method. But we're going to execute on the type API. So first thing we do is we do RPC register. So we're going to register master. And then RPC handle HTTP. And now we're going to create a listener, and we're going to handle the error from setting that listener. And it uses net.listen, and it's going to be a TCP call. And we're going to listen on port, let's say 4000. So you know we don't put a host name in here. So let's handle this error, just in case it comes back. This is great for debugging. Trust me, you want to handle these errors. Log fatal listener error. I'm not too creative with naming my errors. All right, and next, let's just let us know that we're actually listening. Make sure that all worked, otherwise we'll be staring at a blank screen. And you got to put that above this. This is the HTTP, the serve command. You have to put it above here because this actually launches a Go routine that does not return. So if you put print line below, you'd never see it. All right, we need to create a couple other things in here. First, we should probably call the server function as well with an instance of master. But we need to create a structure for our data types that we're passing. So let's create our arguments structure. Now we're going to make a simple adding program just so that we can show some input and output. So we're going to add this int to this int. Remember to capitalize both the structure name and the variables in here so that we can export them. And we need a reply structure so that this is the one the master will actually be sending back with the calculated value. And we should probably actually make this function to do this calculation. So let's create an add function, and this is going to be called externally. So make it of type. It's a method. It's going to execute on master API add, and in order to use this with RPC, we have to have two arguments. So one is the in arguments that it accepts, and the other is the reply argument that it sends out, and it has to return type error. All right, so let's just return the value of our two added arguments. So we use reply return is now equal to add this to this. And that's pretty much it for our master. Let's just print something out here too so that we know when we're getting a request sent to us. And of course, we are returning error type, so let's do nil. So yeah, that's it. That's our master function. Pretty straightforward, pretty simple. If you've implemented RPC in Go already, which you should have at this point in the class, then you've seen this function or this structure before. All right, let's create a worker now. This will be our client to our master server. Creating a separate directory because we're going to be building them with separate Docker files. Let's call this worker.go. And of course, this is going to be package main. So we need a main function. And first thing we're going to need is we need to actually use the exact same structure for our variables here. It has to be identical. And normally you would throw this into some sort of shared RPC library. I'm not going to bother doing that here just because that's a step you should all know anyways. So let's create a variable of our reply type. Call reply. And we'll do the same for our arguments. Of course, we're getting the error because we're not actually using them just yet. So let's set our arguments to something. So let's add this to just say 1, I guess. And everybody does 1 plus 1, so let's make this 1 plus 2. And for those of you who are computer science students and not math students, it is 3 for the answer. So now that we've set our variables, we need to create our call function. It's actually going to do the work for us of calling the server. So we need to pass it the RPC method, which is the method we'll be calling in master, which is as a string, and then we're going to pass it our arguments as an interface, and we're going to pass it the reply as an interface. And let's make it return a bool just so we know what happened. I don't like returnless functions. So let's just let ourselves know that we've called this function. So we're making a request. And we're going to use the dial function. Let's just call it dial, and we're going to want the error from that, if there is one. So we're going to do RPC dial HTTP. And we're going to pass it the same values here. So TCP, but this time, because we're going to point it to a server, we're going to call master port 4000. And the way we're going to set up our Docker container, master will actually resolve to whatever IP address the master gets from the network when it first starts up. So let's catch this error. Again, my creative error identification naming. And then we need to make sure that we close this call at the end of this function. So we'll just do a defer dial close. And let's make this, we want an error from this if it doesn't work. So we're going to use the call method on dial, and we're going to pass it the method, the arguments, and the reply. This is the one that's actually doing all the work for us. Just make sure that error. Now, if it comes back as no, because we have to return a bool here for yes or no if it worked. So I'll do return true if it worked fine, and if it failed, we'll just make a log of that error. I suppose you figured out by now that dial.call actually does return error type. And we'll return false if we get to this point. Okay, so that's pretty much it for our worker. Pretty simple. Let's actually call the call function now. So we actually do something. And we're going to pass it API and add. So remember, we created our instance of the master as API. We're going to pass it pointers to args and reply. And then let's actually print out what we get back so we know it actually did something. Because we need to know what 1 plus 2 is. And the most complicated distributed calculator ever made. So we asked the master to add this to this, and it told us that that equals that. Very exciting. So this will be args dot this. This will be args dot to this, and of course our reply. All right. Now we're gonna Dockerize the daylight out of this. All right. So let's just make sure we got everything here. Everything is here. Okay. So let's create a Docker file in each one of these folders so that we can very quickly build them. This is where a lot of the Dockerization occurs. So we're going to call from Golang latest. This is a Docker image, a base image that is available on Docker Hub. It's nice and small, very useful. And we're going to declare our working directory. Let's just call it /app, I guess. And then we need to copy everything from our actual local directory here that we're working in to app in the image. And then we're going to run make directory because we're going to share volume here. We don't have access to an actual shared file system, so let's just call it shared. This is make the directory in the image, by the way. And we're going to declare a shared volume of shared. So this means that they will share a file structure at shared. And we need to make an entry point so it actually does something when it starts up, otherwise it'll exit. So go run master.go. There we go. Very simple Docker file. I know there's a lot missing here, and normally you would add quite a bit more. some environment variables that aren't set, but this will work. Let's do the same for the worker, and it's pretty much identical, except at the end we will call worker.go instead of master.go. So let's just copy the master Docker file to the worker Docker file and change this to worker. There we go, that's our Docker files. Now, see everything. Yeah, so let's see what we got going on here. Let's just review this. We're making an API type, and then we're creating an instance of that API. And then we've got our add function here, very straightforward, or it's a method now. Don't forget we need to add 2 arguments and make it return an error, and capitalize, of course, because it's going to be exported. Let's see, in our server, very straightforward. We're not declaring a server name because we're just listening on port 4000. We're not sending anything just yet. It'll create the return path to whoever calls it. And then in our worker, we're creating a very simple math calculation here, and we're calling API.add. And we pass in arguments of reply, and then this comes down here. We use the down, RPC, HTTP. Okay, so this is all good. Everything looks like it's working. So that calls add in here. And then, yeah, master. Don't know if I mentioned this already, but we're going to create our own network, and Docker will resolve master to the IP address for this particular container within that network. That's like its own little DNS server. So, and the world's simplest Docker files. All right. It's pretty good. Let's start running this. So let's open a terminal. Come on, already open here, and it's already set to the worker directory, or sorry, the master directory that I'm in, and we're going to do a network creation because we're going to create our own network. So it's just Docker network create. Let's call it RPC net, and that worked. And let's list our networks, and you can see it right there at the bottom. These are all the networks I currently have running in Docker. And we're going to check our images. We have the Golang image already installed. If you don't have it already installed, don't worry about it. That Docker file will actually retrieve it when we do build for you. It'll take a few seconds. So we do Docker build. We're going to tag it master and dot. Don't forget the dot. And it's going to find that Docker file and build it all ready for us. And then we're going to run it. So we do run network equals RPC net, because we need to tell it what network to attach to. And we're going to give this a name. You're going to name the master master. And that's how it's going to resolve to master when you do the RPC call. And then, of course, tell it what image, master image. And it's listening. Cool. Let's do the same for our worker. So, same thing, Docker build, tag it as worker. And dot. Don't forget the dot. And now we're going to run it. We're going to attach the same network. So network equals RPC net. And we're not going to name it. It'll generate a dynamic unique name for us, and that's because we're going to have multiple workers. So if we have the same name, it's going to create resolution issues. And let's run it. And look, there we go. Signal that it got a request at the server, and it returned 1 plus 2 equals 3. And if we open our Docker dashboard, we can see we have 2 containers running. One is the master, and one is Friendly Williams. That's a good name for a worker. And it just exited. We could put a loop in there if we want to keep that container running, but we don't. Let's try it again. Let's run multiple workers here. So do the same thing. Docker run network RPC net worker. And there we go. And you see we got another getter request over here in the master, and it returned 3 again. Let's do it one more time. just because I have an extra square. And Docker run, network RPC, worker. There we go. Works great. Get through request. So that's how you set it up. And the shared volume, you just point anything to directory shared. And when you create a shared directory volume, what it'll do is it'll do it in the root directory of where you are running Docker. So thanks for watching. Also, it can't be an already created directory. Thanks. Have fun.